If you could lift it up, taste, pain, visceral sensation. Meaning, because our viscera, okay, so like if we walk into something and bump something and hurt our arm or whatever, we kind of know that, all right? Our organs, our viscera, can't really relay that information if they're hurt. So they have to have a way to let us know something is wrong. So usually what will happen is, if that organ is hurting, okay, it usually tells you by making a certain area of your body hurt. Like your liver would make you hurt through here, okay? The bladder makes you hurt in certain areas. So your viscera have to have a way to let you know that they're in pain. So we get our visceral sensation, consciousness, emotion and empathy, and cardiovascular homeostasis. In my parietal lobe, taste, somatic sensation, body, sensory integration, integrating the information, visual processing, spatial perception, language processing, numerical awareness. My occipital, strictly sight, because that's pretty busy. Then my temporal, hearing, smell, emotion, learning, language comprehension, memory consolidation, verbal memory, visual and auditory memory, language. Are you using all of those 24/7? You kind of learn, and that's what your cerebrum is going to help you do. Maintaining the body as a whole doesn't come to this part of the brain. Does this part of the brain affect the control of the body? Yes. But the actual homeostasis, no. It's not this area of the brain. This is the most recent area of the brain on the geological time scale. And it took a long time for it to pretty much develop to the point that we have it today. What's currently happening evolutionarily with this part of the brain? Is it continuing to evolve? No. It's devolving. Can you think of reasons why?
Age.
Age will affect the tissue, which will affect its abilities. We no longer work with our hands and our eyes and our body. Everything is now automated for us. Does not need to make the brain cells fire. Does that make sense? So this area of the brain is actually devolving. The primitive region is pretty much like it is, because it's maintaining the homeostasis. Now, in something about this part of the brain, do you see something called a post-central gyrus and a pre-central gyrus? Now, let's take a peek at this. They're trying to color code it for us, okay? Where you've got like the frontal, parietal, temporal, occipital, that sort of thing. If you look at the brain, the model that you have. You got to kind of look at it together, the two halves together. Do you see where it looks like there's a line between these gyri that goes all the way across both halves? Okay. Kind of see that? Okay. Yep. Mm-hmm. Okay, so the way that we're looking at this, okay, that line is called my central sulcus, a central line, okay? And do you see how it looks like it's got that one big fold in front, one behind, giving us pre-post, okay? Keep that in mind. That's going to come back to us. This pre and post central gyrus, that's going to come back to us. So just kind of remember that for right now. All right. So any questions up to this point? Okay. We'll stop there today. Pick up on Thursday.